Hey guys, this is just a video about maximum area and when we had fixed perimeter, just an example of one that we had you do in class. So basically, we have a perimeter of equal to 160, and that's going to be its set. So we have 160 feet of fence, say, and we want to maximize our area. Well, one way we can do that is we can just draw a bunch of things that have a perimeter of 160. So I know, like for instance, the smallest one, would have, if you're using whole numbers, would have a length of 1, because you can't, if we're using whole numbers, and then so if this is 1, that's the 1, so that means it's 158 you have left. So you're going to divide that into the two spots here, and you get 79. So that means you have a 1 by 79 rectangle would get you a perimeter of 160. Another one would be a 2 by, and then if this is 2, then that's also 2. So now, you'd have 156 left, which would mean that this and this would be 78. So a 1 by 79 or a 2 by 78, both of these will get you a max area. I'm sorry, a perimeter of 160. But you'll notice that these have different areas. So like 1 times 79 is 79 units cubed. But this one has a area of 2 times 78, which would be 156 units squared. So vastly different area, vastly different shapes that have different room inside the shapes. So if we're looking for the max area, we can sit here and we can actually make a table and a list of every single one of these that would have you a perimeter of 160. That would take a really long time. So one of the things that we can do is we can develop an equation that would help us graph it on our graphing calculator. And just a reminder, the equation you're going to have is quadratic. Because if you did a list of all the different, if we would say width versus areas, as your width is small, your area is small, and eventually your area is going to become this maximum number, whereas every other width below that moves on, the area wouldn't actually get bigger, it would actually get smaller, and it would develop a parabola shape, which would mean that this actual relationship is a quadratic relationship. Well, how do you actually find? We have to be able to graph it on our graphing calculator in order to, we need to find the equation. So how do we do this? All right. So this might seem complicated at first, but you really follow the same steps throughout every one of the problems where you have a fixed perimeter to maximum area. So let's start by knowing that we're going to have to graph an equation, and we're basing it all on the relationship between area and length and width. So we know that an area formula is A equals LW. But this would have 3 different variables, which you cannot graph. So what we're going to do is we're going to use the information that we do know. We do know that the perimeter is 160, and perimeter is equal to 2L plus 2W. Well, if you can solve one of these for the variable, we can actually plug it back into this formula, and we'll only have one variable to use. So whether you want it to say L equals or W equals, it actually doesn't make a difference. I'm going to get this to say L equals, so I'm going to solve it for L. Divide by 2. Remember, both things get divided by 2. And you're left with L equals negative W plus 80. Now, I'm going to go ahead, and now that I have another name for L, I can plug this information back into my equation. And I can simplify this by multiplying by W by distributing. I'm left with area equals negative W squared plus 80W. And in order to be able to graph it, I'm going to assume that area is my Y, and my width will be my X coordinate. So now if I go into my calculator and use this quadratic equation, this will give us a parabola so that my perimeter is always 160, but it will show us the different options that you would have for the area depending on what the width is. So go to my calculator, go to Y equals, clear this out, and the equation was negative X squared, and I think it was plus 80X. Now you really don't even have to see your parabola. If I go to my table, I can see all the different widths that we can have, and what the area would be. And I can see like when the width is 7, the area is 511. And if I go down, I can see that the area is going up. It's going up all the way into the thousands. And I can see right here, it gets to an area of 1,600, and then the area starts becoming smaller as even though my width is increasing by 1. So I can see right here that the width that would produce the greatest area is a width of 40. So if I go back, and here remember that our length, another name for our length is negative w plus 80. Well, since I now know that the width is 40, I can actually solve this for the length and get negative 40 plus 80, which is 40. The other way that you can do this on your calculator is to actually see the parabola. So you can see right now my window is not set up where I can't actually see where, but I know that it goes, the highest it goes is 40. So I'm going to go into my window and change my Y maximum to 40. And I'm going to go ahead and change my X max to also 40. Or maybe I'll change it to 50 just to see if that's far enough. And when I hit graph, I should be able to get a better idea of what my parabola is. So it's really skinny, so that probably means that I'm a little too far on my X. See all this wasted room right here? So let me go back to my window. And I'll still make this 20. Oh, so that actually means it goes further out this way. So I'm going to actually increase everything to be, why don't I make it 100, and I'll go my Y max. Even though I know the highest it goes is 40, I'm going to make it a little higher. I'll do 100. Oh, so I can see that it should go up even a little higher than that. Oh, you know what? I forgot. I was actually thinking of that it goes up to 40, but remember our area, if I go back to my table, the highest it goes up to is 1,600. So I made a little mistake there. And it actually, 40 is the point where it gets to it. So we're going to keep our X at 100. So it goes past double this would be 80. So we know it's going to come down at 80. And I got to go up to about, we'll have it go up to 2,000. And now I can see my parabola. So to find out the maximum value, I could go to second, calc. 4 is the maximum. Left bound means put it to the left of the point we're trying to get. So I'm going to go a little left, hit enter. Right bound, I'm going to go to a little bit to the right of it, enter, and then guess, I'm just going to hit enter. And I can see right here, 40, when there's a bunch of zeros, it just means that you moved a little bit too far or a little bit too far to the right. So our maximum is the width of 40, and you get a Y or an area of 1,600. So those are the two ways to figure out your maximum area based on your perimeter. Oh, you know what I did not talk about is what is the domain. So remember that if this point right here is at an X of 40, that means that it's going to come down over here at 80. So we can't have a, so that means that your domain is always going to be between 80 and 0, because you can't actually have a coordinate of 80 or 0, because if you made this 80 and this 80, that would be 160. That would mean that the width would have to be 0. Now, width can't be 0. So we know that our domain is between, or our X is between 0 and 80, but not including 0 and 80.